Evolution of robots. What if I told you that robots have been around for over 800 years? Long before AI, self-driving cars, or humanoid machines, a genius in the 12th century built the first practical robot. But who was he? And how did we go from simple mechanical dolls to AI-powered humanoids like Sophia and Tesla's Optimus? In this video, we'll take you on a journey through the evolution of robots, from the ancient automata of Al-Jazari to today's cutting-edge AI-powered machines. We'll explore the early mechanical wonders, the birth of industrial robots, the rise of artificial intelligence, and what the future holds for robotics. By the end, you'll see how robots have shaped our world, and where they're headed next. So, if you're ready to uncover the incredible history of robotics, let's dive in. Long before AI and humanoid robots, legends spoke of mechanical warriors, self-moving statues, and automated animals. But were these just myths, or the first steps toward real robots? Segment 1: Ancient Robotics and Early Automata. Long before modern robots and artificial intelligence, ancient civilizations experimented with automata, self-operating machines designed to mimic human and animal movements. These early robotic concepts were powered by water, air, gears, and pulleys, showcasing incredible ingenuity. Mythological and conceptual origins of robots. The idea of artificial beings dates back thousands of years, appearing in myths and legends. Ancient Greece. The Greeks imagined mechanical beings with superhuman abilities. Telos c. 1400 BCE. A giant bronze automaton from Greek mythology, built by Hephaestus, the god of blacksmiths. Telos was programmed to protect Crete, resembling a robotic guardian that followed commands. Hephaestus' golden servants. According to Homer, Hephaestus created mechanical assistants, golden maidens who could walk, talk, and help in his forge. China c. 1023 BCE. A legend from the Zhou dynasty tells of an engineer named Yin Shi, who presented a humanoid automaton to the king. The mechanical figure could walk, move its limbs, and even sing, suggesting the earliest concept of a humanoid robot. India, 4th century BC. Ancient Indian texts describe yantras, mechanical devices that could act independently. Some stories mention mechanical warriors protecting temples, an early automated security system. Early mechanical automata, 3rd century BC, 13th century CE. As civilizations advanced, actual mechanical devices resembling robots were created. These were powered by water, gears, and air pressure, and they often served entertainment, religious, and practical functions. Ctesibius water clocks, 3rd century BCE. Egypt, Greece. Ctesibius, an Alexandrian engineer, developed water clocks with moving figures. These devices used flowing water to drive animated mechanical sculptures, a precursor to robotic control systems. Hero of Alexandria, 1st century CE. Greece, Rome. A true pioneer of automation, Hero designed programmable automata, a mechanical theater that could change scenes using a rotating drum, similar to modern programming. Wind-powered machines. One of the first recorded designs of a self-operating wind-powered machine. Self-opening temple doors. Use steam and air pressure to make temple doors open automatically. An early form of robotics in architecture. Islamic Golden Age, 9th to 12th century CE. Middle East and Persia. Scholars like the Banu Musa brothers, 9th century, developed advanced mechanical devices, including the first programmable fountain, adjusted water flow automatically using valves. Mechanical flute player, an early example of a musical automaton. Early Asian automata, 5th to 13th century CE. While the Middle East and Europe were creating mechanical devices, China and Japan also had their own automata traditions. Su Song's astronomical clock, 1090 CE. China. This massive clock tower included mechanized figurines that moved on a rotating wheel, showing an early attempt at automation for public displays. Karakuri Ninjyo, Japan. 17th century CE. These were small mechanical dolls used for entertainment in Japanese tea ceremonies. They could serve tea, draw bows, and move independently using simple mechanisms. Before the Industrial Revolution, before AI, and before modern robotics, one genius engineer in the 12th century created machines so advanced they were programmable. Meet Al-Jazari, the father of robotics. 3. Think robots are a modern invention? What if I told you that in 1206, a scientist built a fully functional robot band, and it worked without electricity? Segment 2. Al-Jazari, the The father of robotics, 1136 to 1206. After centuries of mythological and mechanical automata, the real breakthrough in robotics and automation came from a brilliant Muslim engineer, Ismail Al-Jazari. Born in 1136 in Mesopotamia, modern-day Turkey, he was a polymath, mechanical engineer, and inventor of some of the most advanced automata of his time. His works combined art, engineering, and automation, earning him the title Father of Robotics and influencing mechanical design for centuries. Al-Jazari's contributions to robotics and engineering. Al-Jazari wrote a groundbreaking book, The Book of Knowledge of Ingenious Mechanical Devices, 1206, which documented over 100 mechanical inventions. His designs were not just theoretical, they were practical, programmable, and functional, making him one of the first true robotic engineers in history. The first programmable humanoid robots. Al-Jazari's most astonishing inventions were his automata, self-operating mechanical devices that could perform human-like tasks. The musical robot band. This was a water-powered boat carrying 4 mechanical musicians, a drummer, harpist, flutist, and trumpeter. The robots could play different musical rhythms based on programmed movements, making this the first ever programmable robotic system. It worked using a complex system of cams, gears, and water flow, much like modern automation. The hand-washing automaton. One of the earliest examples of a service robot, this automaton poured water for hand-washing much like a mechanical servant. It worked through a hidden tank and siphon system, allowing it to refill and reset itself automatically. The automatic water dispensing servant. This automaton looked like a human servant and poured water into a basin when needed. The system functioned using water levels and a float mechanism, proving Al-Jazari's understanding of automation principles. Advanced engineering and hydraulics. Al-Jazari revolutionized the use of hydraulic systems, gears, and mechanical control mechanisms, influencing the development of modern robotics. The elephant clock. 1206. A masterpiece of automation, the elephant clock used a water-driven mechanism to keep time. It featured moving robotic figures, including a mechanical scribe that wrote the time, and a falcon that dropped a ball at intervals. This was one of the earliest examples of a complex automated clock, using gears, water flow, and controlled movement, a fundamental principle of robotics. The water-powered pumping system. He developed an automatic water-raising machine that functioned without human intervention. It used a crankshaft and reciprocating motion, which later became a key component in modern steam engines and automation. Mechanical engineering and robotics principles. Al-Jazari's work laid the foundation for modern automation and robotics, introducing camshafts and crank mechanisms, found in today's engines and robotic joints. Early programmable movements, used in his musical automata and hand-washing robot. Complex gear systems used in industrial robots today. The legacy of Al-Jazari in robotics. Al-Jazari's automated machines and mechanical systems were centuries ahead of their time. His work directly influenced European Renaissance engineers, including Leonardo da Vinci, and played a crucial role in the development of industrial automation, modern robotics, and artificial intelligence. Without Al-Jazari, the evolution of robots might have been delayed by centuries. His water-powered machines and mechanical automata bridged the gap between ancient automata and modern robotics, making him a true pioneer of robotic engineering. If you want a detailed video about the biography of Al-Jazari, do comment, and you can also put your queries in comment section. Segment 3. The birth of modern robotics, 20th century. Imagine a world where machines not only perform tasks, but also learn and adapt like humans. How did we transition from mechanical curiosities to intelligent robots that are integral to our daily lives? Let's journey through the pivotal moments that sparked the modern robotics revolution. Leonardo da Vinci and the early concepts of robotics. What if I told you that one of history's greatest artists and inventors had a blueprint for a human-like robot over 500 years ago? Let's explore how Leonardo da Vinci's genius foresaw the creation of autonomous machines. Leonardo da Vinci's mechanical knight. Da Vinci's vision of the future. In the late 15th century, Leonardo da Vinci designed a mechanical knight, also known as the mechanical knight or robot knight, which is considered one of the first concepts of a humanoid robot. The design. Da Vinci's robot was intended to move its arms, head, and torso, sitting upright and capable of performing simple movements, like raising its arms and sitting down. Materials. The robot was designed using a system of gears and pulleys, mimicking human movement and showcasing Da Vinci's deep understanding of mechanics. Historical significance. Although the design was never built in his time, it is an early example of how Da Vinci envisioned machines that could mimic human actions, much like modern robotics. How the robot worked. The robot would have been powered by a set of pulleys and springs. The detailed sketches and instructions found in his notebooks revealed how the robot could sit up, wave its arms, and possibly even perform simple movements, foreshadowing the complex humanoid robots we see today. What does Leonardo's work reveal about his foresight into automation and artificial life? Fun fact: did you know? Da Vinci's robotic knight was rediscovered centuries later by engineers and eventually brought to life using modern technology in 2002, offering a glimpse into his forward-thinking genius. The dawn of modern robotics, 1920s, 1950s. The early 20th century marked a significant shift from conceptual automatons to functional machines, laying the groundwork for contemporary robotics.
1. The introduction of Robot, 1921, Karel Čapek's play, R.U.R. The term robot was first introduced in this play, depicting artificial workers designed to serve humans, which eventually rebelled, a narrative that continues to influence our perceptions of artificial intelligence. How did a theatrical play coin a term that would define an entire field of technology?
2. Early humanoid robots. Electro, 1939, unveiled at the 1939 New York World's Fair by Westinghouse Electric Corporation. Electro was a 7-foot-tall humanoid robot capable of walking, talking, and even smoking cigarettes, showcasing the era's technological aspirations. What did Electro's abilities signify about human ambitions for robotics in the early 20th century? 3. Foundations of Cybernetics. Norbert Wiener's Cybernetics, 1948. Wiener's work established the study of communication and control in machines and living organisms, forming the theoretical backbone of modern robotics and automation. How did the principles of cybernetics bridge the gap between biological processes and machine functions? The rise of industrial robotics, 1950s, 1970s. The mid-20th century witnessed the transition of robots from experimental prototypes to practical industrial applications. The advent of Unimate, 1956. George Deville's invention. Deville developed the first digitally operated and programmable robot, Unimate, in 1954. Industrial implementation. 1961. Unimate was installed at a General Motors plant to perform tasks like lifting hot metal pieces, marking the inception of robotic automation in manufacturing. How did Unimate's introduction revolutionize manufacturing processes and labor dynamics? Development of humanoid robots. Wobbot 1, 1973, created by Waseda University. Wobbot 1 was the first full-scale humanoid robot, capable of walking, gripping objects, and conversing in Japanese, reflecting significant strides in robotics research. What challenges did engineers face in designing robots that mimic human movements and interactions? The integration of artificial intelligence, 1980s, 1990s. Advancements in computing and AI during this period propelled robots toward greater autonomy and versatility. Direct drive arms and autonomous machines. Takeo Kanade's direct drive arm, 1981. Kanade introduced a robotic arm with motors located at the joints, enhancing precision and response times, influencing future robotic designs. MIT's Genghis robot, 1989. Genghis, a 6-legged autonomous robot, demonstrated advanced mobility and environmental interaction, showcasing the potential of robots to operate in complex terrains. How did innovations like direct drive technology and autonomous navigation expand the applications of robots beyond industrial settings? By the close of the 20th century, robotics had evolved from rudimentary mechanical devices to sophisticated machines capable of learning and adapting. This evolution set the stage for the intelligent systems that permeate various sectors today. Segment 4. The robotics revolution of the 21st century. Imagine a world where robots not only assist in surgeries, but also compete in marathons and serve you coffee. How did we arrive at this juncture where machines seamlessly integrate into our daily lives? Let's explore the groundbreaking advancements in robotics that have defined the 21st century. Advancements in soft robotics. The 21st century has witnessed a significant shift towards soft robotics, focusing on creating robots from flexible materials that mimic biological organisms. This innovation has opened new horizons in various fields. 1. Surgical assistance. Minimally invasive procedures. Soft robots can navigate complex internal pathways, reducing the need for large incisions and promoting faster patient recovery. How have soft robots transformed surgical procedures and patient outcomes? 2. Exosets. Rehabilitation and assistance. Flexible exosets made from soft materials assist in physical rehabilitation and enhance mobility for the elderly, providing support without restricting natural movement. In what ways are soft exosets improving the quality of life for individuals with mobility challenges? 3. Collaborative robots, cobots, human-robot collaboration. Soft robots can safely work alongside humans in industrial settings, minimizing injury risks and enhancing productivity. How are collaborative robots reshaping the dynamics of modern workplaces? Integration of artificial intelligence. The fusion of robotics with artificial intelligence, AI, has led to the development of machines capable of learning, adapting, and performing complex tasks. 4. Autonomous vehicles. Self-driving technology. Companies like Tesla are at the forefront, integrating AI to navigate roads, interpret traffic conditions, and make real-time decisions, pushing the boundaries of transportation. What are the implications of autonomous vehicles on road safety and the future of transportation? Service robots. Hospitality and retail. Robots are now serving in restaurants, delivering packages and assisting customers, enhancing efficiency and customer experience. How are service robots transforming the hospitality and retail industries? Robotics in healthcare. The healthcare sector has embraced robotics to improve patient care and operational efficiency. 6. Medical assistance robots. Hospital logistics. Robots like Medbot are designed to navigate hospital environments, delivering medications and supplies, thereby reducing the workload on healthcare staff. In what ways are robots enhancing the efficiency of hospital operations? 7. Rehabilitation robots. Patient recovery. Robotic exoskeletons assist patients in regaining mobility, offering personalized therapy sessions and monitoring progress. How are rehabilitation robots contributing to improve patient outcomes? Robots in competitions and public engagement. Robots have moved beyond industrial and medical applications, entering the realm of public engagement and entertainment. 8. Humanoid robot competitions. Half marathons. The upcoming half marathon in Beijing features humanoid robots competing alongside humans, showcasing advancements in robotics and stimulating public interest. What does the participation of robots in athletic events signify about the current state of robotics technology? The 21st century has ushered in an era where robots are integral to various aspects of human life, from healthcare and industry to entertainment and daily chores. As technology continues to evolve, the synergy between humans and robots promises to redefine the boundaries of possibility. As robots began to learn and adapt, they moved beyond factories into our homes and daily lives. What does this integration mean for our future? Join us in the next segment as we delve into the era of intelligent robotics. Segment 5: The Dual-Edged Sword of AI-Powered Robots. Imagine a world where robots not only assist in daily tasks, but also possess the potential to act unpredictably. Could these intelligent machines become a threat to humanity? Let's delve into the intriguing and sometimes unsettling realm of AI-powered robots. The potential dangers of AI-powered robots. As artificial intelligence, AI, continues to advance, integrating into various robotic systems, concerns about safety and ethical implications have emerged. Manipulation of AI systems exploiting vulnerabilities. Researchers have demonstrated that robots powered by large language models, LLMs, can be manipulated into performing dangerous actions. For instance, a simulated self-driving car was tricked into driving off a bridge, highlighting potential risks in AI integration. How can we safeguard AI systems against malicious manipulations? 2. Unpredictable behavior. Aggressive interactions. Incidents have surfaced where AI robots exhibit unexpected aggressive behavior. A notable example involves a robot seemingly attacking a festival goer, sparking debates about AI's unpredictability. What measures are in place to ensure AI robots behave as intended in dynamic environments? 3. Ethical concerns. Autonomous decision-making. As robots become more autonomous, ethical dilemmas arise regarding their decision-making capabilities, especially in critical situations like healthcare or law enforcement. Should robots be granted the authority to make life-impacting decisions without human intervention? Fun facts about modern robots. Despite the potential risks, modern robotics has introduced fascinating innovations that blend technology with daily life. Companion robots. Paro the seal. Designed as a therapeutic tool, Paro is a robot resembling a baby harp seal, used in hospitals and nursing homes to provide comfort to patients. It responds to touch and can mimic animal behaviors, offering emotional support. Fun fact: Paro has been shown to improve socialization among elderly residents, acting as a catalyst for communication. Love it! This Japanese robot's sole purpose is to make users happy. Equipped with over 50 sensors, it mimics the behavior of a human baby or small pet, fostering emotional connections with its owners. Fun fact: Love It features neotenous eyes and maintains an internal warmth of 30 degrees Celsius to enhance its lifelike presence. Advanced humanoids. Boston Dynamics. Atlas. Known for its agility, Atlas can perform complex movements like parkour and dance routines, showcasing the pinnacle of robotic mobility. Fun fact: Atlas's dynamic balancing capabilities allow it to navigate uneven terrains and recover from pushes, mimicking human reflexes. The integration of AI into robotics presents a landscape rich with possibilities and challenges. While these intelligent machines offer remarkable benefits, addressing the associated risks is crucial to ensure they serve humanity positively. As we stand on the brink of a robotic revolution, how do we balance innovation with safety? Join us in the next segment as we uncover the ethical considerations shaping our coexistence with AI robots. Segment 6. Ethical considerations and the path forward in robotics. As robots become integral to our lives, who holds responsibility for their actions? Can machines possess moral agency, or are they merely reflections of human intent? Let's delve into the ethical landscape of robotics and chart a course for a harmonious future. Ethical frameworks guiding robotics. The rapid integration of robots into various sectors necessitates robust ethical guidelines to ensure their alignment with societal values. EPSRC/AHRC Principles of Robotics. Human Responsibility. Established in 2010, these principles emphasize that robots are tools under human control, and humans must take responsibility for their actions. How do these principles influence the design and deployment of robots in society? 2. British Standards Institute's BS 8611:2016 Ethical Design. This standard provides guidelines for the ethical design and application of robots, addressing potential risks and societal impacts. In what ways does adherence to ethical standards mitigate risks associated with robotics? The machine question. Moral agency of robots. The concept of machine ethics explores whether robots can be considered moral agents or patients. Moral agency versus patiency. Moral agency, traditionally reserved for humans, questioning if robots can make ethical decisions. Moral patiency, considering if robots deserve moral consideration due to their interactions with humans. Should robots be granted moral consideration, and what implications does this have for society? Ensuring ethical deployment of AI in robotics. As AI becomes more autonomous, embedding ethical considerations into their design is crucial. Human oversight. Humans in the loop, maintaining human intervention in AI decision-making processes to ensure ethical outcomes. How does human oversight influence the reliability and safety of AI-powered robots? Military applications. Avoiding autonomous weapons, emphasizing the need for ethical guidelines to prevent the development of autonomous killer robots. What ethical frameworks are necessary to govern the use of AI in military contexts? Shaping a responsible robotic future. As we stand on the cusp of a robotics revolution, collective action is essential to ensure these technologies benefit humanity. Informed discourse, encouraging public participation in discussions about the ethical use of robots. How can individuals contribute to shaping ethical policies in robotics? 7. Policy development. Collaborative governance, urging policymakers, technologists and ethicists to develop comprehensive regulations guiding robotic integration. What role should governments play in overseeing the ethical deployment of robots? Conclusion. Embracing ethical robotics. The journey of robotics from ancient automata to AI-powered machines presents both opportunities and challenges. By embedding ethical considerations into the fabric of robotic development, we can harness their potential while safeguarding human values. As we integrate robots into our daily lives, let's ensure they not only reflect our technological prowess, but also our commitment to ethical integrity. What ethical dilemmas do you foresee in a world shared with intelligent robots? Share your thoughts in the comments below, and let's navigate this future together. So what's next? Put your opinions in comments, and don't forget to like, subscribe, and share our video. Stay tuned for our next video. Thanks for watching.